Okay, we're going to look at our last topic for this rationals unit, and it's solving rational equations. And if you remember back to adding and subtracting rationals, we have to have common denominators. The same thing applies for rational equations. You got to make sure your common denominators are the same. And then once they are, the denominator is basically ignored. So if we look at this one on the title page, we have 3, 2, and 6. So we can actually make our denominator 6. If we times our first fraction by 2 and our second fraction by 3, so we'd end up getting 2x over 6 plus 3 over 6 equals 3x plus 1 over 6. So now that they're all 6, if all the bottoms are the same, that means the tops have to be equal. So that means all we have to do is actually solve the top equation. So we'd have 2x plus 3 equal to 3x plus 1. If we bring the 2x over and bring the 1 over the other way, so we'd end up getting 2 equals x. And that's it. So that's our answer to the question. We could plug it back into the original, so you could put a 2 in for each x and multiply it all out, and you would see that you get the exact same answer. And we don't need to worry about non-permissibles in this case unless our answer is a non-permissible. That's the only time you got to be a little bit careful. So when we're doing our steps, we basically have to have common denominators. So do that first. Again, make sure all your fractions are the same denominator. Then we only need to simplify and solve our numerator only. So we don't need to worry about the denominators once they're the same. And be careful, sometimes the numerator will give you a quadratic equation. So that's where you have to factor or use the formula or graph or whatever to solve. And then, like I just said, make sure you check your answers to see that they aren't a non-permissible. If they are non-permissible, we call those answers extraneous, which means they don't work. So we just got to make sure we choose the answer that actually works for the equation. So let's go through a few examples. So the first one here, we can see we have just an x, but we could write that as x over 1. So now you can see our common denominator would be x plus 1. So we just need to times. Okay, so for our common denominator, we want to have it as x plus 1, so we just want to multiply the top by x plus 1 and the bottom by x plus 1, so those will be the same denominators. And once we do that, like I said, we don't need to worry about the denominator anymore. We would just have the numerators. So we'd have x plus 1 and x plus 1, but we ignore that. So let's just FOIL out the top. So you'd have x squared plus x, and on the other side we'd have x minus 3. And that's it. So we need to solve that equation. Let's bring the x over. So we'd have x squared. Those will cancel. So we'll have x squared equal to negative 3. And if we try to square root both sides, that means there's no solution. So this one actually doesn't work, which is possible. Sometimes you just won't get an answer that works out. Okay, if it was something like x squared equals 4, then our solutions would be 2 and negative 2. So just like we did before with the last unit, use your quadratic formula, solve by square rooting like I did here, factoring, graphing, whichever. Okay, the next example here, we've got 4 and x on the bottom, so that will be our common denominator. We need to change each fraction to be over 4x. So our first one, you can see we're missing the x, so we times the top by x, will give us x squared. Times the second one by 4, which will give you 28. And the last one we have to times by 4 and x, so that would be 12x. So this one now, our tops will be x squared. Let's bring the 12x over, make it equal to 0. So you can see if we solve this one by factoring, we would get 14 and 2, minus 14 and plus 2. So that means our solutions are positive 14 and negative 2. So we actually get 2 different answers, and both will work in this case to give us the correct answer. So you could plug both of them into the original, and they indeed will work. Okay, let's try a couple more that are a bit harder. So this next one, you can see the denominators look quite a bit different, but if we factor them, just like we did for adding and subtracting, if you factor the bottom, you can see we have x plus 2, x minus 2, 6, x plus 2, x minus 2 again. So everything, our common denominator will be 6, and x plus 2, and x minus 2. So all we have to do is figure out what we're multiplying the top. We won't bother rewriting all the bottoms, we just need the top. So the first one, we got the x plus 2, x minus 2. we just need to times it by 6. So that'll give us 12. The second fraction, we got the 6 and x plus 2. We're missing the x minus 2. So if we multiply those out, that would be 10x minus 20. And our last one, we got the 1, or the x minus 2. We're missing the 6 and the x plus 2. So we'll multiply those out, gives us 6x plus 12. So now our last step is, let's just simplify all this. So we'd have 10x minus 8, 6x plus 12. Bring the 6x over. So we get 4x minus 8 equals 12. Bring the 8 over. Would give us 20. Divide by 4. X equals 5. And once again, if we plug that into the original, it would indeed work out. And we don't have to worry about our non-permissibles. Remember, our non-permissibles in this case would be 2 and negative 2. So as long as our answer isn't 2 or negative 2, then we're good. Okay, this next example, same sort of thing. We got y minus 3, y minus 6. If we factor the bottom, we'd have y minus 3 and y minus 6 for our two factors. So you can see those are our common denominators. So all we have to do is times our 9 by y minus 6. Times our 4 by y minus 3, and we're good. So we'd have 9y minus 54 for the first one, minus 4y, be careful that minus, so negative 4 times y would be minus 4y, minus 4 times minus 3 will be plus 12, equal to 18. So if we simplify that, we get 5y minus 42 equals 18. Let's bring the 42 over, it'll be 60. Divide by 5 will give us 12. And again, that's not a non-permissible, so we're good. So our last thing we got to look at is some word problems. So when you get word problems with rationals, you have to just basically write the equation first and then solve it. And usually the hard part is writing out the equation. So this first type we're going to look at are distance speed type questions. So in this case, we've got 120 kilometers. She was on her bike, swam for 12 kilometers, and her speed was 8 times faster than swimming, 9 hours total. So lots of information. So what you want to do with these questions is put them in a chart. So she cycled for 120 kilometers. She swam for 12 kilometers. It said her cycling speed was 8 times faster. So if we call swimming x, cycling would be 8x. And from physics, our time is going to be our distance divided by speed. So we just want to write that as 120 over 8x, and the other one would be 12 over x. And so that means our time for cycling plus our time for swimming will equal 9 hours, it said. So that ends up being our equation. So the chart will help you kind of set up your equation. Once we do that, you can see our common denominator now will be 8x. So the first fraction will be good, times our second fraction by 8. So that'll give you 96 over 8x. And times our 9 by 8x, which would be 72x. So our equation will simplify to 120 plus 96, which would give us 216. Equals 72x. 216 divided by 72 is 3. So what that means is our speed for swimming then is 3, because that's what we called our x. Let's go back to our chart here. So our speed for swimming would be 3. Our speed for cycling will be 24, right? 8 times 3. And we can check that out. So 12 divided by 3 would give us 4 hours. 120 divided by 24 gives us 5 hours. Those do indeed add up to 9 hours. So we're done. So the question was, what was her swimming speed? So in that case, we're just looking for the 3 kilometers per hour. Okay, another type of question is areas, volumes, things like that. So in this case, we have some sort of rectangular shape. We don't know the length and width, so let's call this L.W, but we do know the area is 144. And it says we're going to change the rectangle so that our width is doubled, so that'll be 2W, and our length is decreased by 12, so L minus 12, and it'll still have the same area. So our new rectangle then will be 2 width times L minus W equals 144. So the trick to this one is we want to solve that equation, so let's write that out. So length times width will equal 144. But the problem is we have two different variables. So if we take our first equation and we go length times width equals 144, we can actually solve for one of those. So it doesn't matter which one. Let's solve for W. So that'd be 144 divided by L. So that's what we're going to substitute in. So in this case, we'd have 2 times 144 over L times L minus 12 equals 144. So if we actually simplify this a little bit, 2 times 144 would be 288 over L times L minus 12. And we can actually multiply that out again. So we'd have 288 minus whatever 288 times 12 is. Let's do that calculation. So that's 3456 over L equals 144. So you can see our common denominator in this case is L. So if we times our other two things by L, top and bottom, and that's it. So we would get 288L minus 3456 equals 144L. And let's rearrange that equation. Let's bring the 144 over. So that would be 144L when we subtract. Let's bring the 3456 to the other side. So 3456 divided by 144 equals 24. So if we go back to our original then, that means our original length was 24. Our new length is going to be 24 minus 12, which would be 12. And if we go 144 divided by 24, that gives us a width of 6 originally, and 6 times 2 is 12. So our original rectangle then was 24 by 6. Our new one is 12 by 12. So that's going to be our correct answer. All right, our last type of word problem that's quite common is what I call job sharing. So you can see it says it takes Bob 20 minutes to shovel his driveway, it takes Bill 30 minutes to do the same job. How long would it be if they both do it at the same time? So what you want to be careful with this one is a lot of people just say, well, 20 and 30, if we average those out, you'd get 25 minutes. Well, that doesn't really make sense, because if one guy can take 20, he's not going to take longer if he has somebody helping him. So let's use a little bit of logic again. So if Bob took 20 minutes by himself, and if Bill was the exact same speed, that means it would take them 10 minutes together. Or if they were both the same speed as Bill, so 30 and 30, that would take 15 minutes together. So we're basically going to split somewhere between 10 and 15. So we should get an answer of like 12, 12.5, something around there. So that should be the right answer. So the trick is, how do we get this question? So what we want to do is we want to call X our total time. So if our total time is right around 12 minutes or so, we would say, what percentage does Bob do out of that total time? So if the total time divided by 20 minutes, that would give you Bob's percentage, plus the total time divided by 30 minutes, that would give you Bill's percentage of the job he does, and together they're going to do one complete job. So that ends up being our equation. So if we do common denominators now, our common denominator in this case will be 60. So we would times our first fraction by 3, times our second fraction by 2, and we'd have to times our 1 by 60 as well. So our equation ends up being 3x plus 2x equals 60. So that gives us 5x equals 60, and 60 divided by 5 is 12. So that means the total time it would take them would be 12 minutes. We estimated about 12 and a half, which was the average, but it does make sense because Bob's a little bit quicker, so it should be a little bit less than the 12 and a half. Like 12 and a half would be if they were exactly the same rate. Because Bob's a little bit quicker, it should end up being a little bit quicker. So 12 minutes is our total answer. And that's it. We're done.